Hello students and welcome back to this new session. In this session I am starting with the module 4. In this module you will be learning the numerical solutions of linear differential equations, basically of first order and first degree. Now already in your previous semesters you will have learned the various analytical methods of solving a linear differential equations of specific type. But in the real world problems, the physical problems, the differential equations that arise from such problems may not be of the same type. Sometimes you may not be able to solve such differential equations. Okay, so we need to use or we need to go for an alternative way of solving such differential equations. Therefore, this numerical way of solving those differential equations gives you the approximate solution for such problems. Okay, to 5 methods to learn in this module. I guess 5 methods, completely 5 methods. So one by one we'll be starting. First amongst them is Taylor series method. Okay, so one by one we'll start learning all of them. Okay, so pay attention all of you. Now let us first understand how do we solve a linear differential equations using Taylor series method and what we do exactly in that Taylor series method. The Taylor series method is easiest of every this. You just have to refer Taylor series for that. It's very simple. For example, suppose you are given with a differential equation dy by dx is equal to f of xy. F is a function of both x and y, some function of xy you can say, with some initial condition, with the initial condition y of x naught is equal to y naught. That is, initially x is taking the value x naught, correspondingly y is taking the value y naught at that point. Okay, so this will be some differential equation given to you with the initial condition. Okay, if that is the case, how do we use Taylor series over here? We do nothing here, we just take the Taylor series, or we expand the Taylor series about the point x is equal to x naught, so that in the neighborhood of x naught we can find out the value of y at any point in the neighborhood of x naught, I can say. So for example, say I am considering the solution, say I will expand the solution y is equal to y of x. Okay, y is equal to y of x as Taylor series in the powers of x minus x naught, that is about the point x naught. Okay, so you can write it as x of y of x naught plus, because this value will be having y naught, plus x minus x naught into y dash of x naught plus x minus x naught square divided by 2 factorial into y double dash of x naught plus x minus x naught whole cube by 3 factorial y triple dash of x naught plus so on. Okay, these are your Taylor series about the point x is equal to x naught. Now if I ask you to work for any value of y, find the value of y. If I ask you to find the value of y, find y in the neighborhood of x naught. Say, suppose I can just give you an example. Say your x naught is suppose 0 and you are working for y at the point y of 0.1. So 0.1 is the neighborhood of x naught, very close to 0, is it not? Similarly, you can even work for y of 0.2. Okay, because maybe this value can be, say y naught is 1 or something like that. I'm just giving an example for that. Okay, so in problems also you will be given with the initial conditions and you will be asked to work for the value of y in the neighborhood, in the somewhere very close to x naught. You will be asked to work for the value of y. Okay, so let us see how to work with the problems. With problems it will be still clear to all of you. Just you have to consider the Taylor series according to the question. If sometimes it is not mentioned, you will see it in the problems. It's not a big deal. Okay, let's continue with the problems. It will be still clear. Now listen to me carefully. There is one problem for you. Let us start with the problems and understand how to solve the problems using Taylor series. Okay, here is one problem for you. Using Taylor series, find y of 0.1, considering the expansion up to, I should write here, considering the expansion up to the 4th degree terms, given that dy by dx is equal to x minus y square and y of 0 is equal to 1. Okay, so the given equation is dy by dx is equal to x minus y square and the initial condition is what? Y of 0 is equal to 1. It means what? X naught is equal to 0, correspondingly Y naught is 1. This is the initial condition for you, okay? Now first what we have to do, we have to consider the Taylor series up to 4th degree term, because we have to consider, yes, because it has been mentioned in the question. So let us expand the solution y is equal to y of x up to 4th degree term. So let y is equal to y of y of x naught plus x minus x naught into y dash of x naught plus x minus x naught square divided by 2 factorial y double dash of x naught plus x minus x naught cube divided by 3 factorial y triple dash of x naught plus x minus x naught to the power 4 divided by 4 factorial y fourth dash of x naught plus so on. Okay, so we have expanded our Taylor series up to 4th degree. So this should be our first step. Apart from that, we should also mention what are the given things for us. The given thing is what? This is dy by dx. Dy by dx is nothing but y dash. So y dash is equal to x minus y square with the initial condition y of 0 is equal to 1. It means x naught is equal to 0 and y naught is equal to 1. So x naught is equal to 0 and y naught is equal to 1. We are going to substitute those values over here. Let us do that. So we will have y is equal to y of 0, which is 1, is it not? Y of x naught. Y of x naught means y of 0. Y of 0 it's given to be 1. So let us write it. 1 plus x minus 0, it means it will be x. Y dash of 0, I don't have its value. So it is actually y dash of 0. Let me correct it. So it is y dash of 0 plus x minus 0 again square, it becomes x square by 2 factorial, which is 2. Y double dash of 0 plus x minus 0 whole cube, it will be x cube by 3 factorial, which is 6. Y triple dash of 0 plus x to the power 4, x minus 0 to the power 4, it becomes x to the power 4 by 24, because 4 factorial is 24. Y fourth dash of 0 plus so on. Now already we have done the substitution, so this should be this step. I hope up till here everyone is clear. Okay, now we have to evaluate these values. Okay, these values in this complete expansion, these values are missing, so we need to evaluate this. Now to evaluate this, what we will do, we'll consider the given equation. Okay, take down the given equation. You have y dash is equal to x minus y square. So I want y dash of 0. It will be what? 0 minus y of 0 whole square, or it is 0 minus 1, which is minus 1. Is it not? Because you are going to work for the value of y at the point x is equal to 0. So it will be y of 0 whole square. Now y of 0 is 1. So it becomes 0 minus 1, which is equal to minus 1. Now I want y double dash, isn't it? So for that, let us differentiate the given equation with respect to x. So when we differentiating this with respect to x, this equation. So if you differentiate, you will get y double dash is equal to 1 minus 2y dash. Derivative of x is equal to 1 minus derivative of y square is 2y into y dash. Yes, that is dy by dx. In place of that, you need to write y dash. Okay, so I want y double dash of 0. So it will be 1 minus 2 times y of 0 into y dash of 0. Now 1 minus 2 times y of 0 is 1. Y dash of 0 is minus 1. So it will be 1 plus 2, or it will be 3. Just see that. 1, 2 times 1 into minus 1, it becomes 1 plus 2, which is 3. This is the value. Similarly, let us differentiate, because we need to even work for y triple dash and y fourth dash also. So go on differentiating the same equation. This equation you are going to differentiate now. So if you differentiate this, I am not rewriting it again. So you just simply differentiate this equation. You will get y double dash you had. So y triple dash is equal to derivative of 1, 0 minus derivative of this combination. So it will be 2 times y as it is, derivative of y dash is y double dash, minus 2y dash as it is, 2y as it is, 2y dash you keep as it is, then derivative of y, again y dash you get. Okay, so so it will be y triple dash of 0 is equal to minus 2 times y of 0 into y double dash of 0 minus 2 times y dash of 0 whole square I can write, because it is y dash into y dash square. Now let us substitute. It is 2 times minus 2 times y of 0 is 1, y double dash of 0 is 3, minus 2 times y dash of 0 is minus 1 square you will get actually. So it is minus 6 minus 2, which is minus 8. Minus 8 should be the value. I will just mark all the important values because you should not get confused. So these are the 3 values we have got. Now we have to, I'll just simplify this further. It is minus 2 times y double dash minus 2 times y dash square you have got. Okay. Now this is your y triple dash. Since I have to work for y fourth dash of 0, I need to again differentiate this with respect to x. So it becomes y fourth dash is equal to derivative of this. It is minus 2 y as it is, derivative of y double dash, it is by triple dash, minus 2 y double dash as it is, derivative of y, it is y dash, minus derivative of this, it is 4 times y dash, derivative of y dash square is 4 times y dash, because already there is 2, so it is 2 times 2, it is 4 into y dash into y double dash. This is what you get. Or when you further simplify this, it is minus 2 times y triple dash minus 6 times y double dash into y dash. This is what you get. Okay. Now from here I want y fourth dash of 0. So it is minus 2 times y of 0 into y triple dash of 0 minus 6 times y double dash of 0 into y dash of 0. Let us substitute the values. So y of 0 is 1, minus 2 times 1, y triple dash of 0 is minus 8, minus 6 into y double dash of 0. Y double dash of 0 is 3, y dash of 0 is minus 1. So add all the values. It's plus 16 plus 18. Plus 16 plus 18 you will have. So it will be 34. Okay. So all the values we have found. Now all we have to do is do the substitution part. Okay. That is, in this equation, you have to substitute y dash of 0, y double dash of 0, y triple dash and y fourth dash of 0. All the values we have found, we have to substitute and simplify. Let's do that. Okay, so we have got y is equal to, I hope it is seen there, 1 minute, I'll just adjust this properly. Okay, so you have y of 0, which is 1 plus x into y dash of 0. Y dash of 0 is minus 1, write minus 1 over here, plus x square by 2 you had, y double dash of 0, y double dash of 0 is 3, write 3 over here, plus x cube by 3 factorial, which is 6, y third dash of 0, which is minus 8, plus x to the power 4 by 24, into y fourth dash of 0, which is 34, plus so on. Okay. Now this will be equal to 1 minus x plus 3x square by 2 minus 4x cube by 3. You simplify this. 3, 4 over here. Similarly here, 17 you will get. Here you will get 12. Okay. So plus 17 x to the power 4 by 12 plus so on. Okay, this is what you get. Okay, now I want y of 0.1 as it has been asked in the question. So I need y of 0.1, 1 minus 0.1 plus 3 times 0.1 square by 2 minus 4 times 0.1 cube by 3 plus 17.1 to the power 4 by 12. So use your calci to evaluate this. It is 1 minus 0.1 is 0.9 plus 0.1 square is 0.01 divided by 2. So 3 by 2 also it can be written as 1.5 there, you can do that, minus, even this fraction can be simplified, 4 by 3, it should be something like 1.3333 something you will get. Okay, just see that. This is 0.003, okay, 0.1 cube plus 17 by 12 also you have to see it in your calci. 0.1 to the power 4 is this. Okay, then just simplify this in your calci. You must end up with 0.9138. 0.9138. You just see in your calci, put all the numbers, you will end up with 0.9138. Okay. So I hope this problem is clear to all of you, but still if you have any doubt, you can ask me in my WhatsApp group. Okay. Continue in my next session. Thank you.